Summer is here, and with it, there's lots of fun happenings in the world of astronomy. In this episode, we'll let you know which planets will be visible and when and how to see them. There's going to be a decent meteor shower, and the moon won't really interfere. Also, we'll learn about the lunar crater Plato. And there's a comet that will beat its best in early July. And after all that, we'll explore some of the best summer showcase deep sky objects. So sit back and enjoy, and let's get to the July skies. Welcome to the Astro Guy podcast. I'm not an expert, I'm an amateur like you. I'm here to learn and here to teach. So let's enjoy the ride together. Carpe Noctem, seize the night. Welcome to the Astro Guy podcast. I'm your host, Wayne Zuhl. Mercury is in the evening sky all month after sunset, and will be best seen about 30 minutes after sunset until Mercury sets soon after. If you have an excellent western horizon, the evenings of the 9th and 10th will likely be your best days to spot Mercury, which will be shining right around magnitude 0 in the constellation Cancer. While starting the month at magnitude negative 0.5, and spanning almost 6 arc seconds in diameter, Mercury shows a 67% gibbous phase. As July rolls on, it dims and shrinks in apparent size, ending July at magnitude plus 0.9, while spanning about 9 arc seconds in diameter and showing a 28% illuminated crescent. Venus is lost in the sun for most of the month. Keen-eyed observers with an excellent western horizon might be able to spot it in the twilight glow late in the month. In August, Venus will be easier to spot in the evening skies. On the morning of July 1st, around 4 a.m., Mars will be 4.5 degrees east of the 23.5% waning crescent moon. This should be stunning in binoculars and with the naked eye. Mars begins July in the constellation Aries and is shining at magnitude 0.98. with its disk spanning just under 6 arc seconds in diameter. On the 30th, Mars will be 4 degrees south of the 26% illuminated waning crescent moon. Mars ends the month slightly brighter at magnitude 0.9. Its disk is still spanning around 6 arc seconds, but it will appear larger as the year goes on. Jupiter spends all month in Taurus. On the 1st, Jupiter rises at 3:24 a.m. and is bright at magnitude minus 2.03. The disk of the planet spans just over 33 arc seconds. Jupiter ends the month a bit brighter at magnitude minus 2.09 and appears slightly larger at 35 arc seconds across. On the 31st, Jupiter rises at 1:40 a.m. On the morning of July 3rd, try to spot the thin 7.7% illuminated waning crescent moon, just 4 degrees north of Jupiter. On the morning of July 30th, the moon, Mars, and Jupiter make for an interesting looking triangle in the pre-dawn skies. Saturn is the star as far as the planets go this month, beginning the month rising at midnight on the 1st. By the end of July, Saturn rises just before 10 p.m. Saturn spends all month in the constellation Aquarius. On the 1st, the ring planet is glowing at magnitude 0.9, and the disk of the planet spans 17 arc seconds, while with the rings, the system is just over 41 arc seconds wide. The rings appear nearly on edge, and will be on edge in the spring of next year, before opening up again over a period of several years. This is due to the alignment of Saturn in its relationship to Earth as it rounds the Sun. By the 31st, Saturn will have increased in brightness to magnitude 0.75, and it will also increase in size slightly by about 1 arc second more than it was at the start of the month. On the night of the 25th, look for the waning gibbous moon about 7 degrees northeast of Saturn. Uranus is in Taurus all month and can be found about 6 degrees southwest of the Pleiades. This distant world is glowing at magnitude 5.85, and spans almost 4 arcseconds across. If you're under very dark skies, you could spot Uranus with the naked eye, while in binoculars it will appear as a bluish star. A telescope will be needed to reveal the disk of the planet. On the morning of July 15th, Uranus will be half a degree north of Mars, so you can use Mars if you need to that night to help you find Uranus. Faint Neptune spends all month long in Pisces and will be about 11 degrees west-northwest of Saturn. Neptune is dimly glowing, magnitude 7.7, and spans about 2.5 arcseconds across. Neptune rises at 20 after midnight on the 1st, and nearly 2 hours earlier at the end of the month. If meteor showers are something you enjoy, the Delta Aquariid meteor shower peaks on the morning of July 30th, where as many as 20 meteors per hour can be spotted. The peak of this shower does fluctuate a bit, and the Delta Aquariids can be visible starting around the 18th of July and can be seen through the first week in August. The moon will be a waning crescent on the 30th and won't interfere with meteor watching until early in the pre-dawn hours. The shower's radiant, however, is fairly low in the south, reaching about 30 degrees above the southern horizon for those at 40 degrees north latitude. Scan an area from the Great Square of Pegasus to Saturn. Scanning east and west will yield you the best results to spot them. Try to be in a very dark location with a good southern horizon to have your best view of these meteors. Another great thing happening this month is July has a comet that will peak in brightness on the 1st, low in the northwest sky. Periodic comet 13P Olbers is expected to reach 6th magnitude by the 1st. As I write this, the comet is at magnitude 6.8, with a coma spanning nearly 5 minutes wide and a faint tail that extends for about 20 arc minutes in length. Binoculars or a telescope will be needed to spot Comet Olbers. I'll leave a link to a finder chart in the show notes. Last month, we published an episode all about T Corona Borealis, the blaze star. The link is in the show notes. As of this writing, the blaze star is still around 10th magnitude, but astronomers are still predicting that the star will go nova any time between now and the fall. When it does, the star will brighten to about 2nd magnitude and slowly fade over a period of a week or two, fading back to 10th magnitude. It will be fun to see an extra star for a few nights in Corona Borealis when the nova occurs. Last month, I also mentioned SpaceX's Starship and Boeing's Starliner test flights. The Starship launched on June 6th, and both the booster and Starship performed great. Both craft made soft landings in the ocean, despite the Starship seeing one of its flaps ablating away during re-entry. It looks as though the next Starship test flight will see actual landing attempts where the craft will be recovered. Boeing's Starliner experienced several delays, but finally launched successfully on June 5th, and later, again after some delays, it docked with the ISS. The crew, which were supposed to have returned to Earth after a week on the station, have been stuck there as engineers are working through the telemetry data to hash out the problems that the Starliner experienced with helium leaks and some maneuvering thrusters that weren't firing. As of this recording, Butch Wilmore and Sonny Williams are still on the ISS and are expected to make the return trip in early July. Congratulations go to the Chinese Space Agency for their successful Chang'e 6 mission, which landed on the moon's far side. It robotically collected samples and successfully returned them to Earth on June 25th. These will be the first ever samples returned from the moon from the lunar far side. Expect the data and some samples to see their way into the global astronomical community later this year. Now it's time for the
Lunar Feature of the Month.
This month we're going to explore the crater Plato, named for the famous Greek philosopher. This large, circular crater can be observed through 10-power binoculars, although the best views will be through a telescope. Located on the northern edge of Mare Imbrium, the crater is easy to spot on the western edge of the mountain range Montes Alpes. The crater itself is nearly 63 miles in diameter and is nearly 2.5 miles deep. It's relatively young, at around 3.8 billion years old. The floor of the crater is noticeably flat, as after the impact that caused it, lava flows filled in the floor of the crater. It's best seen one day past first quarter to one day before last quarter. Moving on to our deep sky tour, let's examine some of the best showcase deep sky objects that can be seen on summer evenings. These objects are great whether you're observing by yourself or entertaining friends on a nice clear night. We'll begin our tour in Scorpius with the large bright globular cluster M4, which is cataloged as NGC 6121. It is one of the closest globular clusters to us, lying at a distance of a little more than 6,000 light-years. It measures 75 light-years wide and is comprised of more than 100,000 stars. It's not just close to us, it's also one of the oldest known globular clusters, with an age of around 12.8 billion years old. The cluster is bright at magnitude 5.6, making it just visible to the naked eye under very dark skies. It spans 26 arc minutes in size, appearing nearly as large as the full moon. In binoculars or a small telescope, the cluster appears as a hazy, round patch of light. Through a 6-inch scope, you'll begin to resolve some of the individual members of the cluster. In an 8-inch or larger scope, you'll see even more stars, especially near the center of the cluster. Even though this is low on the horizon, it's still a beautiful, rich cluster that should wow anyone. M4 is easy to locate. Start at the first magnitude red star Antares, known as Alpha Scorpii, and sweep just over 1 degree west, and you'll spot M4. After enjoying M4, you can move a bit to the east and explore another great globular cluster in Sagittarius. I'm referring to the Great Sagittarius Cluster, M22. This is one of the biggest and brightest globular clusters in the entire sky. The cluster shines brightly at magnitude 5.2 and spans 32 arc minutes in size, appearing slightly larger than the full moon. M22 contains about 80,000 stars in a ball that's about 100 light-years wide. The cluster lies 10,600 light-years away from us. Astronomers using radio observations of M22 have detected several black holes within the core of the cluster. M22 is also one of only 4 globular clusters in our galaxy that is also home to a planetary nebula. Unfortunately for us, the planetary nebula is 15th magnitude, and it's very small, so it's nearly impossible to see using all but the very largest amateur telescopes. If you want, you can look up information on this nebula, which is estimated to be only 6,000 years old. Just look up its catalog number, GJJC1. That rolls off the tongue, doesn't it? After all, we're looking at showcase objects, so we're not going to focus on GJJC1. In binoculars, M22 appears as a large hazy glow, while any 3-inch or larger telescope should begin to reveal its member stars. I've been able to resolve individual stars using my 70mm refractor from a dark location, and the cluster looks amazing in my 8-inch Dob. Finding M22 is a breeze. Start at magnitude 2.8 Caus Borealis, the star that represents the top of the Teapot asterism in Sagittarius. Now sweep 2 degrees east and 1.5 degrees north, and you'll be looking right at M22. Our next showcase object is nearby M22, so when you want to explore something different, just sweep 7 degrees west of M22 and nudge your scope about 0.5 degree south, and you'll be looking right at our next target, M8, the Lagoon Nebula. M8 is a large complex of emission nebulae that surrounds the 4th magnitude open cluster NGC 6530. The cluster spans 14 arc minutes wide and contains several thousand stars, although in a 6-inch telescope under dark skies, you should see a couple dozen member stars in the cluster. But we're not here for the cluster, we're here for the Lagoon Nebula. M8 shines at magnitude 4.6 and is an easy naked eye target under dark skies. The Lagoon Nebula spans 90 by 40 arc minutes in size, so it's best viewed at low magnifications. Classified as an emission nebula, it is one of only 2 star-forming regions that are visible to the naked eye for observers in the northern hemisphere, the other being M42, the Orion Nebula. The lagoon is about 4,100 light-years away from us and spans 110 by 50 light-years in size. In binoculars, M8 appears as a large oblong glow, with some modeling from the stars in the cluster within it. But in a telescope, you can spend hours exploring this nebula. Using my 8-inch Dobsonian with a 35mm eyepiece, it yields a magnification of only 26 power, and it shows the entire complex of the lagoon. You can easily make out the clusters and lots of stars within the nebula. The nebula itself has lots of bright and dark areas. The bright portion in the center of the nebula was named the hourglass by Sir William Herschel, as it does resemble an hourglass. My favorite views of M8 were through my 8-inch Dob many summers ago in Vermont. If you're observing from a light polluted location, using a nebula filter will help you to see the structure within the nebula. It's an amazing sight in virtually any instrument, and I'm sure that you'll enjoy it and enjoy showing it to your friends and family. Our next object is one that we discussed in last month's What's Up episode, but it's too good of an object to leave off of a list of summer showcase objects. I'm referring to M13, the Great Globular Cluster in Hercules. M13 is widely regarded as the best globular cluster for observers in the Northern Hemisphere. It was discovered by Edmund Halley in 1714 and added to Messier's catalog in 1764. M13 shines at magnitude 5.8 and spans 20 arc-minutes in size. It has a radius of 84 light-years and is situated just over 22,000 light-years away from us, and it contains between 100 and 300,000 stars. Under dark skies, M13 appears as a faint, hazy patch of light to the naked eye. In binoculars, you can actually see some of the cluster's brightest stars, while a telescope will resolve dozens, if not hundreds of stars. I've spent countless hours observing this cluster in all kinds of different instruments. In my 8-inch SCT, the cluster appears large and bright, with hundreds of stars visible. Even in my 70mm refractor, the cluster is partially resolved and looks large and bright. Finding M13 is also very straightforward. First, locate the keystone of Hercules. The star Retilicus, with a magnitude of 2.85, marks the southwestern corner of the keystone. Imagine a line from Retilicus to the magnitude 3.45 star Eta Herculi. M13 lies about 5 degrees along this line from Retilicus to Eta. It's one of the easiest deep sky objects to locate. As the evening goes on, another great object that's sure to wow friends and family is the next stop on our tour. Messier 11, also known as the Wild Duck Cluster, is one of the most impressive open clusters that's visible to Northern Hemisphere observers. First discovered by German astronomer Gottfried Kirch in 1681 and later added to Charles Messier's catalog in 1764, M11 is located in the constellation Scutum. It shines at magnitude 5.8 and spans almost 23 arc-minutes wide. This makes it easily visible through binoculars or small telescopes. M11 is located about 6,200 light-years away from us and spans about 20 light-years across. This dense cluster contains nearly 2,900 stars, many of which are young, hot, and blue. The name Wild Duck Cluster originates from the distinct V-shaped pattern formed by its brightest stars, which resemble a flock of ducks in flight. M11 is notable for its rich star field and dense core, offering a spectacular sight through a telescope, where individual stars can be resolved, revealing the cluster's true beauty. I've seen M11 in many different instruments, and it always looks great. Locating it is a pretty easy task. Look halfway between the top of the teapot in Sagittarius and Altair. Now look for the 4 stars that form a hook-shaped asterism. M11 is at the bottom of the hook. Next on our list is one of my very favorite binocular objects, and it's amazing in a telescope at low power as well. I'm referring to Colander 399, which is commonly referred to as Brocchi's cluster or the coat hanger. Technically, it's not a cluster at all, but an asterism, which is a group of stars that's smaller than a constellation. The Big and Little Dippers, as well as the Teapot, are all examples of asterisms. While Brocchi's cluster looks very much like an old wooden coat hanger, the kind with a straight piece of wood and a hook, the asterism is made up of 10 stars. The coat hanger shines at magnitude 3.6 and spans 1.3 degrees wide. It's easy to spot with the naked eye from a dark location. None of the 10 stars are thought to be gravitationally bound to one another, meaning that they do not form a star cluster or an association. This fact was confirmed by measurements taken by the Hipparcos satellite in the late 1990s. To locate the coat hanger, spot the tiny constellation Sagitta, the arrow. The 2 stars marking the tail of Sagitta will point north and slightly east. Follow this line for 2.5 degrees, then sweep 2 degrees to the east and you'll spot the coat hanger. The last showcase object on our list is Messier 27, also known as the Dumbbell Nebula. It's one of the most striking planetary nebulae in the night sky. Discovered by Charles Messier in 1764, M27 is located in the constellation Vulpecula and is about 1,360 light-years away from us. This nebula is the glowing remnants of a star that has shed its outer layers at the end of its life cycle. The central star, a white dwarf, is surrounded by a vibrant shell of ionized gas, which emits light in various colors due to the presence of different elements, primarily hydrogen and oxygen. The Dumbbell Nebula gets its name from its distinctive shape, which resembles a dumbbell or an apple core when viewed through a telescope. The dumbbell glows at magnitude 6.4 and spans about 8 arc minutes in diameter, making it one of the largest planetary nebulae visible from Earth. The nebula's intricate structure and brilliant colors offer a captivating glimpse into the final stages of stellar evolution. You can spot it as a small faint glow in binoculars. With my 70mm refractor, the nebula is easy to see and appears round with a bright area in the middle. In my 8-inch SCT, the shape is well defined and careful observation reveals lots of details within the nebula. To find the dumbbell, start at magnitude 3.5 Gamma Sagittae, the star that represents the head of the arrow. Then sweep north 3.25 degrees and you'll be looking right at the dumbbell. I hope that you'll go out and enjoy these showcase objects and that they become favorites of yours as well. Well, that's all for this episode. Thank you so much for tuning in, and I hope that you found our time together to be fun and helpful. If you have questions or episode suggestions, please email us at astroguypodcast@gmail.com or leave us a text or a voicemail at 973-404-0380. If you're not already a member, please join the Astro Guy Podcast group on Facebook. You'll find other members, videos, blogs, and lots of other useful information there for your enjoyment. You can also visit our YouTube channel, the Astro Guy Podcast, for past episodes and other surprises. Please subscribe. Please consider leaving us a review on your podcast platform. It helps us to get new listeners. If you'd like to support the Astro Guy Podcast and YouTube channel, you can simply buy us a cup of coffee. The money is used to maintain and update the equipment that we use to create and publish the show. The link is in the show notes. Thank you again for listening, and may your skies be clear. As always, Carpe Noctem, seize the night. I'm Wayne Zool, and this was the Astro Guy Podcast. Thank you for listening. As always, your questions, comments, and suggestions are welcome. Keep wondering. Keep your eyes on the sky. Have fun. Carpe Noctem. Seize the night.